everyone. So welcome to the lecture of mechanics of solids. So hope you know that the mechanics of solids is also called as the strength of materials. So we'll start with the subject that is called as mechanics of solids, or it is also called as strength of materials. Okay, so in this session we need to study the mechanical properties of solids, like elasticity, then plasticity, ductility, brittleness, malleability, etc. And also we need to know how that members are analyzed by considering the mechanical properties of the solid members. It is here we are focusing on the points such as stress, then strain, then the elastic moduli such as the Young's modulus of elasticity, then shear modulus, like that. Okay, so let us start with the important mechanical properties. So inside that, the first we need to look the property called elasticity. The first one is elasticity. So the first mechanical property we are going to deal with is the elasticity. Hope you know that what is actually elastic. So it is very simple actually. So when a body is given a certain force, so it will undergo deformation depending upon the direction of force. So if the force is in the tensile direction, so the object will undergo stretching. And if the force is in the compressive direction, you know that what is actually a compression, it is actually a pushing type force. So due to the action of compression, the body will undergo shortening of length, and correspondingly there will be a decrease or increase in the lateral dimensions. Okay, so depending upon the type of forces, the deformation will be also like that. So what is actually elasticity is, when the object is subjected to a force, it will get strained. Okay, and when that force is released, that object will comes back to its original position or the original shape. So that property is actually called as elasticity. So here you can write, okay, from the definition it is very clear that it is the property, by using that property the material is enabled to retain to its original dimension after deformation on removal of load. So when you are applying a load, so the material undergo the change in shape. It can be the change in length, change in cross section, like that. But upon releasing the force, that material comes back to its original position. Okay, so that property is actually called as elasticity. Now let us look the second property, which is called as perfectly elastic. So there is a slight difference between the elasticity and perfectly elastic. So the first property, it deals with the coming back to the dimension, or the dimension of the object is coming back to its original shape. But the perfectly elastic is that the material again comes back to its original shape or the original dimension after the removal of force. But here, for a perfectly elastic material, so the error while coming back to its original shape or its original dimension, the error will be 0. Okay, so the material that maintains that property, that is when comes back to its original dimension or original shape with 0 error, you need to underline that, with 0 error. So that material is considered as perfectly elastic. So here you can see the perfectly elastic as the second property. So you can write, so under this property, here you can see the definition for that, the material that regains completely. So here you can see it regains completely its original shape. That means here, while regaining that shape, the error is 0. So that material is considered as perfectly elastic material. Okay, so that is the difference between the elasticity and perfectly elastic, because while considering the error in here, the perfectly elastic material got 0 error while coming back to its original shape. Now the third property, And before that, let us look at which are the materials that is considered as a perfectly elastic. So let us look at which all material got a perfect elastic property. So let us look. So the three materials in general, so such as steel, copper and aluminum, are considered to be perfectly elastic within certain limit. Okay, so when you are stretching or when you are compressing that particular type of materials that I listed earlier, such as steel, copper and aluminum, so within a certain limit they will behave as a perfect elastic material. They will regain its original shape with zero error after the removal of force. Okay, so the three examples for the perfectly elastic materials are, okay, so here you can see the three materials, so that is considered as perfectly elastic within certain limit. Okay, now the next one, while comparing the elasticity of two materials, it can be asked for the competitive examination as MCQ. So here, which is the question will be like, which material is more elastic? So the options may be like a mild steel, then rubber, then like copper, aluminum, like that it can be given as options. So you need to know that. So the students will commonly opt for rubber is more elastic than other metals, because the other three options are metals actually. So but the point you need to remember is the mild steel is more elastic than rubber. So that is very important note. So I'll note here so you can copy. So this is a very important note. The mild steel is more elastic than rubber. Okay. Now